Hey guys, Buildzoid here, and today we're going to be taking a look at MSI's X370 XPOWER board. So this is MSI's top-of-the-line motherboard for the X370 chipset. It is also, as far as I'm aware, the most expensive AM4 motherboard you can get right now. So, you know, you'd be expecting great things from a board demanding such a price tag. I'll be going over some of the overclocking features the board has, and then we'll, focus mostly on the VRMs.
Before getting to that, this video is brought to you by the current bundle on the GTX 1060 and GTX 1080 video cards, where you can get Ghost Recon Wildlands or For Honor at checkout. This comes alongside new MSRPs for the GTX 1080 series cards, now down to $500. You can learn more at the link in the description below.
So with that out of the way, let's get started. Starting off with the features. So down here you find a power button, a reset button, and this thing, which is the this is an automatic OC dial, which basically just preloads overclocking profiles. I do believe it goes up to like 4.4 or maybe even 4.5 gigahertz. But I can assure you that 4.4 or 4.5 gigahertz will not work. Ryzen is just not capable of such clocks on water cooling or air cooling, and MSI just puts profiles onto their motherboards that are extremely high for the platform they're on. Like my X99 XPOWER has a 5 gigahertz profile, which is a profile that would work for like top 1% of Haswell E CPUs, not even Broadwell E. So yeah, it's just don't use it and do all your overclocks manually. It'll always give you the best results, rather than relying on some preloaded profiles. Because the problem is, this isn't like some automatic overclocking system. It just loads up a profile that's been put into the BIOS, which gives you really high voltage for certain clocks, so it doesn't tend to work very well. So moving along the bottom edge here, we also find this 6-pin power connector, and this is here to provide extra power to the PCI-e slots. So basically, well, this slot down here, the slot above that, these slots all get extra power from this 6-pin right here, as well as the 1X slots should also be hooked up to that. But basically, this exists if you're running a GPU setup which has a really high PCI-e power draw. A lot of people, like say, when the reference RX 480 came out, a lot of people were worried about the overdraw on the PCI-e slot. Generally speaking, your PCI-e slot is not where you're going to see issues. The main issue with high power draw on PCI-e slots is if you have two cards that really pull a lot of power from the PCI-e slots, or even 3 or 4, then what tends to happen is the 24-pin, the 12-volt connector, the 12-volt pins of the 24-pin connector tend to melt. So, because you push too much power through them, they heat up and, burn themselves, melt the plastic, and basically destroy themselves. So, in order to avoid that, there is this 6-pin connector down here to basically give you extra power for the PCI-e slots, which could come in handy if you're running like a Crossfire setup with really power-hungry GPUs. But yeah, I think this is a little bit unnecessary. For 4-way capable motherboards, it's really useful, but the thing is, this board isn't 4-way capable, though it is one of the few X370 motherboards which has this slot down here wired as X8, as we can clearly see that, the pin, like you can see that the last metal pin connection right there. So that's an X8, X8 slot, that's an X8, and this is an X8 as well. This is an X16, but if you want to run 3-way Crossfire on this board, then you're going to be running X8, X8, X8. And the cool thing about, well, it'll work for Crossfire, it won't work for SLI, because this last slot is going through the chipset, and that might cause some issues, but generally it should work, especially for benchmarks. This won't be a problem. For games, I think you might see some kind of latency issues and other weirdness. So this is a small advantage over some other X370 boards, because a lot of the other X370 boards in this, at like the top, the top X370 boards don't have this last slot as X8. They have X4 here. which Crossfire will still run off of X4, except even in my own testing for like 3D Mark Firestrike benchmarking, X4 starts causing serious issues. Even like X4 is really, really dodgy. So while it'll work, it's really not usable, so to speak. So, you know, it is a nice thing that this is included, but I wouldn't really recommend using it. Now then, moving up to the top of the board, the very last feature that is really useful for overclocking on this board is this right here, which is of course a postcode display. This is really useful if you're debugging like any kind of overclocking issues. If for some reason your system isn't starting up, this is a really, as long as this is working, this is a really good way to figure out what is wrong. So that covers all the various OC features. So with those out of the way, let's take a look at the VRMs. Our two main VRM sections are the Vcore Vrm right here. So that's Vcore. That powers the CPU cores if you're overclocking Ryzen, like your core clock. So you're going from like, say, 3 gigahertz stock on a 1700 to 4 gigahertz or 3.9 gigahertz or whatever your chip is capable of. This is the VRM that is the most important for that. Then up here you find the SoC VRM, and this powers the memory controller and all the other system on a chip parts of Ryzen. So that would be like the PCI-e controller, the SATA controller, the USB controller. There's just the SoC portion of Ryzen is pretty massive, and it has a lot of components in it, and that's all powered by the SoC. In the future, I expect the SoC VRM to also power iGPUs of all the AM4 APUs, which as of right now, I don't think any are currently available to buy. So, yeah, right now I have no idea how important the SoC is. On Ryzen CPUs, it's not that important. The SoC doesn't pull that much power, even though it is it takes up a lot of space on the Ryzen die. It isn't particularly power hungry. When we start seeing APUs, the SoC VRM will be more important, as the iGPU will probably pull all of its power off of that. And iGPUs do pull quite a significant amount of power compared to, you know, just controllers. So those are the two main VRMs you have on this board. Both of them are controlled by this chip right here, and that is a IR35201. This is a 8+ kind of interesting voltage controller because it can do 8+0, 7+1, and 6+2 phase operation. Here it is running in 6+2 phase because we have 1, 2, 3, 4, 5, 6 phases here, which are split up like that. And up here for the SoC, we have actually 4 phases, which are split like that. So we have 1, 2, 3, 4, and that 3 looks terrible. There, that's more 3-ish. So this is a 4-phase. So this gets doubled up. The +2 part gets doubled up, and that's done by IR3598s running in doubler mode. And the 6-phase over here, the Vcore Vrm, is actually running off of also IR3598s, but the IR3598 can both be a doubler and it can be a dual driver. Either or. It can't be both at the same time, but it can either double or it can drive 2 phases off of 2 PWM signals. So you have 3 IR3598s, and those give you your 6-phase Vcore Vrm. So, you know, this is actually a pretty good, well, actually, as far as control schemes are concerned, there's nothing wrong with what MSI has opted for. This is very similar to what you'll see on a lot of other motherboards. They won't necessarily use IR3598s, but they will have, like, they will be using a 6+2 phase initial voltage controller setup. Some of the lower end boards are 4+3 or 4+2. So there's really nothing wrong with this 6+2 phase control setup. So now let's move on to the actual power capabilities of the VRMs. Starting with the Vcore Vrm, we have two low side FETs and we have one high side FET right here. The high side MOSFET is a Nyko semiconductor PK616BA. This is a 7 milliohm RDS on MOSFET at 4.5 volts. But the thing is, this is a high side FET, so we don't really care about RDS on. What we really care about is switching speed, which these aren't really that great at that. And we'll actually get to the result of that soon enough. The low side MOSFET is a Nyko PK632BA, and this is a 3.3 milliohm RDS on MOSFET. And both of the, so this is actually, like, amongst low side MOSFETs, this is not that low RDS on, which low side MOSFETs, the big focus there is really, really low RDS on. High side MOSFETs, you want really, really quick switching, switching. And luckily, MSI is using two MOSFETs for the low side, so actually your RDS on is effectively cut in half. It also has the side effect that the heat put out by the low side of the phase is spread across more surface area, because you do have two MOSFETs creating all the, sharing the current and therefore also the heat load. So this does have, this works okay. However, these MOSFETs really aren't that great compared to what you see on a lot of the other high-end motherboards. And the end result is that this VRM, assuming 1.45 volts output voltage, which is quite a bit, it's like 50 millivolts more than what you want to run a Ryzen CPU at, 300 kilohertz switching frequency, which is sort of the typical switching frequency you will see from most VRMs, as motherboards initially run. Motherboards, GPUs, and everything will typically run between 200 and 500 kilohertz switching frequency, with 300 kilohertz being sort of the preferred one, because lower switching frequency gives you better efficiency at the cost of slightly worse voltage regulation. So that's why I chose 300 kilohertz, because it's the most realistic without having the board in hand and being able to check what it actually runs at. So you have 1.45 volts, 300 kilohertz, and assuming that the VRM is at 125 degrees centigrade, it is capable of handling 252 amps if you can cool 64 watts of heat. That's a real problem. A lot of the other motherboards for X370 have way more efficient VRMs, and way more powerful, actually. This is just not a very good... This is not a very good VRM for a high-end X370 motherboard. It's not going to limit you in any way, shape, or form when overclocking a Ryzen CPU, as Ryzen is actually extremely low current. You're looking at 4 gigahertz, 1.45 volts. For me, in my testing, only seems to pull about 100 amps from the Vcore Vrm, so it's really not a high current demand CPU, but this VRM is really, really significantly worse than all the other ones, even if it won't actually impact your overclocking capabilities, because the control scheme is fine, and it's not like you're going to hit a current limit. It's not like you're going to melt the VRM. It's just not as efficient as the other VRMs, and if you're putting 100 amps through this VRM, you can expect it to put out about 15 watts of heat. So yeah, it's not going to limit you in overclocking, but it is less efficient than the alternatives. It's also lower quality than all the other alternatives, as the other, like, ASRock and Asus both have VRMs capable of excess of 300 amps continuous. Gigabyte has a VRM that does 240 amps at the same parameters as this one here, except it does it with a lot lower heat output and does 100 amps at also way lower heat output. So, if you're choosing X370 motherboards with VRM quality as your number one criteria, this really should not be at the top of your, selection, because this VRM, the Vcore VRM here, is just terrible. Well, it's not terrible. If this was a mid-range board, it would be fine. If this was a low-end board, it would be actually really, really good. But this is a high-end board, and also a really, really expensive high-end board, so that really, doesn't work well here. So let's move on to the SoC VRM. The SoC VRM is the same MOSFETs, except we're looking at a one high side and one low side FET. The end result of that is that, assuming the same, well, not the same, because you don't want to run your SoC above 1.2 volts. 1.2 volts, 300 kilohertz, 125 degrees. The SoC VRM is only capable of handling 164 amps of current while putting out 58 watts of heat. Compared to the other motherboards available in this price bracket, this is even less efficient than the Vcore Vrm. Like, the Vcore Vrm is not so far behind the other competitors, but this is just kind of terrible. Luckily, the SoC on Ryzen CPUs really doesn't pull that much power, so in practice you're only going to be looking at about 20 to 30 amps of current draw and only about 3 to 4 watts of actual heat output, so that's not really a problem. But this VRM, again, is just, it's kind of subpar compared to the other motherboards, which, you know, it's like, if there's other features you desperately need that this board comes with, I'd overlook the VRM issues. But if you're mainly buying this because you want a powerful VRM, this board is not for you. There's better alternatives out there. Now then, let's move on to the memory VRM for the DDR4. And DDR4 pulls very little power. And so this VRM naturally doesn't really, like, you can't go that wrong with it. The same MOSFETs again, and we have one high side and 2 low side FETs here. So it looks mostly like the SoC lost that extra low side FET for space saving reasons, because here we have 2 low side FETs for no apparent reason, because DDR4 is really, really low power. And the end result here with this VRM, this phase setup, the memory VRM at 1.45 volts, because that's a safe running, like, this is a safe voltage to run DDR4 at daily if you're overclocking. 1.45 volts, 125 degrees centigrade, 300 kilohertz switching frequency. This VRM, you're looking at a maximum current capability of 84 amps with 21 watts of heat dissipation. So that's really, really overkill for DDR4, because DDR4 runs in single-digit power consumption for the actual memory sticks. So even if you have 4 sticks of RAM in here, you're not going to be looking at, you know, more than, say, 40 watts of power consumption. And that's really high, actually. That's really, really high for DDR4. Realistically, you're looking at more at like 2 to 3 watts per stick, with 4 sticks is only about 12 watts. So the great news here is, in practice, this VRM will only have to push about 10 amps and will put out about, 1 to 2 watts of heat. So this VRM here is perfectly fine, and in fact, it does have an advantage over a lot of the other motherboards out there, because this is a 2-phase, and many other X370 motherboards, both high-end and low-end, do not go for a single-phase design, though with how low power DDR4 is, having 2 phases may not actually give you any major advantage in practice, even if theoretically it does. Even though theoretically it's better, but in practice it might not be that big a difference. So, yeah, that pretty much covers this board. Honestly, I'm really let down by what MSI has done here. It's compared to past XPOWER motherboards, compared to other past MSI boards, this thing really doesn't compare to the predecessors. It is, the VRM is really not that great for the price point. There's no external clock generator on the motherboard. You do at least get the postcode and the power buttons, and this is actually nice if you really want to run 3-way crossfire, which that would actually be probably, that I would sort of see as an advantage for this motherboard, but I have yet to do my multi-GPU testing for Ryzen and Firestrike, so I'm not entirely, it's like, that's more from a benchmarking perspective. From a gaming perspective, this is completely pointless. And then for some reason, we also have an 8+4 pin, like this right here, which makes 0 sense with the VRM that MSI has paired, given this given this board, because this VRM couldn't, it's just not strong enough. It's first of all, Ryzen doesn't need an 8+4 pin worth of power, ever. There's no scenario where you're going to need that much power. And the other thing is, if for some reason you actually needed that much power, this VRM couldn't handle it anyway. So this really looks like they're trying to make the board look better than it is by putting an extra power connector that nobody's ever going to use. And yeah, you know, it's just, that's a marketing stunt as far as I'm concerned. This right here is a marketing stunt. Overall, for a high-end motherboard, this VRM, the VRM is just not that great. But if there's, as I said earlier, if there's any other features on the board you really, really want, then, you know, there's no issue. The VRM's not going to limit you on overclocking. It's just subpar compared to the competition. So, yeah, that about sums it up for this board, and thank you for watching. Like, share, subscribe if you would like to help out with what we do here at Gamers Nexus. We have a Patreon, you can donate to that. And if you would like to see more PCB breakdowns and other overclocking videos, you can go check out Actually Hardcore Overclocking. If you didn't understand anything I said about VRMs and doubling and all that in this video, then actually my channel has 2 videos explaining both how VRMs work and how doubling schemes work. So, you know, you can go check those out if you're interested. Thanks for watching, and see you next time.